All right, guys, here we go. Talking about particle motion, and now we're going to start talking about net and total distance. So, here we go. The graph below, this represents velocity. This whole graph is v of t, velocity, which is measured here, the units, meters per second. That makes sense because it's just like the first derivative of a particle moving along the x-axis. Remember, particle motion, we're only talking about horizontal distance right now. The question is, at what value or values of t does the particle have no acceleration on the open interval from 0 to 10? Well, if we look at this graph, this is the graph of v of t, this funny looking graph, and we can see a couple of things. If we're thinking about acceleration, acceleration is like the first derivative of the velocity function. So we need to see here, okay, the velocity function, when is there going to be no acceleration? No acceleration. Well, if we look here, here's a cusp, right, at t equals 1. So that means that the derivative is going to be undefined. Let's see. Here, we've got a peak, like a point. We've got another point. We've got another point here. So we know that the acceleration function, a of t, is undefined at all of these. Is undefined when t equals 1, 3, that looks like 6, and 8. It's undefined at these values because there is a cusp on v of t. So the particle has no acceleration at t equals 1, 3, 6, and 8 seconds. No acceleration. Next, express the acceleration, a of t, as a piecewise defined function on the interval 0 to 10. Can I come to you in a minute? I'm just making AP Calc videos. Guys, you can't not be interrupted. Every video I've made you. Every video. So, sorry that you have to hear all this. Okay. Express the acceleration as a piecewise defined function on the interval 0 to 10. Acceleration. That's the derivative. The derivative is just like average rate of change, just like slope, which is convenient that all of these values have got linear, or all these pieces are linear, so we can just look for the slope. So a of t is equal to, this one is up 3 over 1, it looks like, so slope is 3, and that's from 0 less than t less than or equal to 1. Just less than 1, excuse me, just less than, strictly less than 1. And here we're going down 3 over 1, so negative 3. Negative 3 from 1 less than t less than 3. And then here we've got a slope of 0. And this is from 3 less than t less than 6. And then this one is going up 3 over 1, so positive 3. 3 from 6 to 8. Notice all of these are exclusive because we can't find the acceleration at these points. It's undefined there, undefined. That's why all of these are open intervals. And the last one, it looks like it's down 3 over 2, so I'm just going to put it next door because I ran out of space. Negative 3 over 2, and that is from 8 to 10. So there's our piecewise defined function for acceleration. Okay, for what values of t is the particle moving to the right, to the left? Justify. Okay. Moving to the right. It's moving to the right when velocity is positive. Left. We said this, I think, in the last video. When velocity is negative. So the particle is moving to the right when v of t is greater than 0, and this happens from 0 to 2. Here it's all positive. Okay, parentheses move to 2. Okay, so which happens from or on the interval from 0 to 2, and again from 7 to 10. And the particle is moving. The particle moves left when it's negative below. So that's from, or I should really say on the open interval from 2 to 7 when velocity is less than 0. Okay. Find the average acceleration of the particle on the interval from 1 to 8. So the average acceleration, average rate of change, we need the velocity at 1 minus the velocity at 8, 1 minus 8. Velocity at 1 second is 3. Velocity at 8 also happens to be 3 over negative 7, so 0 meters per second squared. The average acceleration on the interval 1 to 8 is about 0 meters per second squared. Okay, now, when is the particle speeding up? When is it slowing down? I think we said this at one point in a previous video, and we said that something is speeding up when the signs are the same, when v of t and a of t have the same sign. Okay, so same sign. Velocity and acceleration. Velocity and acceleration. So let's see here. Let's look at this first piece. On this piece, the graph is increasing and it's positive. So the velocity is positive, and since it's increasing, the acceleration is positive. So we're definitely here speeding up from 0 to 1. 0 seconds to 1 second. Okay, now let's look at this piece here. Here, the velocity is positive, it's above the x-axis, but the velocity curve is decreasing, so the acceleration is negative, meaning that we are slowing down from 1 to 2. And now if we look at this piece here, velocity is negative, it's decreasing, so acceleration is negative. So that's great. And so we are decreasing from, speeding up, from 2 to 3. All right, I cannot continue at the moment because there is a fire drill. So I will pick this back up in a few minutes.